Hi everyone. In our previous video, we talked about determining whether or not two functions were inverses of each other. In this video, we are going to be determining an inverse function just given a one-to-one function. So given a one-to-one function f of x, we can find f inverse of x by the following steps. Step one, we can replace f of x with y. Step two, we're going to switch y and x. Step three, we're going to solve for y. And step four, we're going to replace y with f inverse of x. So we're going to do several examples here to show this process, to show how it works. So here we have g of x is equal to x plus 8 over 7, and we want to find g inverse of x. Okay, so step one, we're going to replace f of x, or in this case, g of x, with y. So anywhere we see g of x, we're going to write a y. So we'll have y equals x plus 8 over 7. Okay, good so far. And now we're going to switch y and x. So anywhere we see a y, we're going to write x, and anywhere we see x, we're going to write y. So step two, we'll have x equals y plus 8 over 7. Step three, we're going to solve for y. All right, so if we multiply both sides by 7 here, okay, we'll get 7x is equal to y plus 8. We can take 8 away from both sides, and we'll get y equals 7x minus 8. And then step four, we replace y with, in this case, g inverse of x. So we'll have g inverse of x is equal to 7x minus 8. And we have our answer. And if you want to check this, you could do the composition function of each of these. Okay, so you could compose g with g inverse and then g inverse with g and confirm that they both give you back x. That's a really quick way to check to see if you got the right answer. Okay, so here, in this next one, we have h of x is equal to 4x plus 13, and we want to find h inverse of x. So let's do that. Step one, okay, anywhere we see h of x, we're going to write y. So we'll have y equals 4x plus 13. Step two, we're going to switch y and x. So we'll have x equals 4y plus 13. Step, not step four, I can't even count. Step three, okay, we're going to go ahead and solve for y. So we'll have 4y equals x minus 13. We got that by taking 13 away from both sides. Okay. Right, so then if we divide both sides by 4, we'll get y equals x minus 13 divided by 4. Okay? And then step 4, we're going to replace y with h inverse of x. And then we have our answer. So not too bad. All right, so on functions that you may or may not have domain issues, we need to note that the domain of f inverse of x is going to be the range of f of x. So we haven't talked about range before, but hopefully this isn't anything new for you. The range of a function is just all of the values that that function could take. Okay, so when you think of the function as a little machine that spits out values, it's all of the values that that function could possibly spit out. Okay, given its domain. So, so here we're going to let f of x equal the square root of 5x minus 25 on the domain 5 to infinity. And we want to find f inverse of x and determine its domain. Okay, so before we do anything, let's figure out what the domain is. So we know that this f of x is defined on 5 to infinity. Okay, And we know that really what they did was they just they figured out the domain for us. We don't have to do that. They got that by setting the everything on the inside of the square root to be greater than or equal to 0, because we have a square root here. We've done this before. So they didn't give that to you. You could find that yourself, but they were friendly enough to give it to us. So we know that all the values we could put into this function are 5 to infinity. So all of the values we could put in will spit out a certain set of values. So if we put in 5, we would get 5 times 5, which is 25, and we have 25 minus 25, which would just be 0, and square root of 0 is 0. Okay, and anything bigger than that, our values would get progressively larger as we go off to infinity. Okay, so as we go off to infinity, obviously that's going to be our range, right? So we're going to have 0 to infinity is the range of f of x. Okay, so we're going to include the point 0. I didn't write a good bracket here, but we're going to include the point 0, and we're going to go off to infinity. So we can put in as big a value for x as we want, but we can't have anything smaller than 0 for an output for our function. Okay, so according to our domain here, if we did anything less than 5, we get a negative number, which doesn't even make sense for this function. So the smallest output we have is 0, and we can go off as high as we want. Okay, so that's the range of f of x. So this is also then the domain of f inverse of x. Okay, so let's go ahead and see if we can find what f inverse of x is. So step 1, we're going to replace f of x with y. We'll have y equals the square root of 5x minus 25. We're going to switch y and x. So we'll have x is equal to the square root of 5y minus 25. So now, step 3, we solve. So we have x equals the square root of 5y minus 25. So now we can square both sides. So we'll get x squared is equal to 5y minus 25. So now we can add 25 to both sides, and we get 5y is equal to x squared plus 25. We can divide both sides by 5, and then we're going to get that y is equal to x squared plus 25 divided by 5. Okay, and so now we can, for step 4, we're going to replace y with f inverse of x. So we'll have f inverse of x is equal to x squared plus 25 divided by 5. Okay, so and you might be wondering now, really on this function f inverse of x, you could plug in negative values here and everything would make sense. So why is it that the domain of f inverse of x is only 0 to infinity? Why is that? Well, that is the only domain that would make sense here, where it is still the inverse of f of x. Any other inputs that are not in the domain that we've defined here, we are now leaving its construction as an inverse of f of x. It's now a different function, I guess you could say. So as long as we're on this domain, we can think of the inverse of 5x minus the square root of 5x minus 25 as x squared plus 25 over 5. Okay, so that's the way that makes sense. Okay, so number 4 here, let's let f of x equal x plus 10 squared. Okay, quantity squared, and we're going to let this be defined on negative 10 to infinity. Okay, and we're going to find f inverse of x and determine its domain. So we've already said we want this to be defined on negative 10 to infinity. And that's going to feel kind of arbitrary. However, we we can determine the domain of our inverse function by that already, and we'll see why that works. Okay, so the domain or sorry to find the domain of f inverse of x, we need to find the range, I guess, of this function, f of x, okay? So here we can see what possible values this could take if we plug in these numbers here, okay? Now, we know that since we're squaring this whole quantity here, right? Since we're squaring all of that, it has to be greater than or equal to 0, okay? So if we plugged in -10, which we're allowed to do, then we know that it's going to be 0 squared, which is 0. And then the bigger x is, the larger our value gets for f of x. So we know that our range of f of x is going to be, again, 0 to infinity. And this is also going to be our domain of f inverse of x. Okay, so let's go ahead and see what our inverse function is. So step one, replace y with f of x. We have y equals x plus 10 quantity squared. Step two, we switch y and x, so we have x is equal to y plus 10 squared. And now we solve. So we can take the square root of both sides. Okay, so we have the square root of x is equal to y plus 10. Can take 10 away. All right, and we have y equals the square root of x minus 10. Okay, now what you'll notice here is that the range of this function is going to be -10 to infinity. So for under the square root here, everything has to be greater than or equal to 0. Okay, so we could plug 0 in, but we couldn't plug anything less than that. So the smallest value we could get for the square root of x is 0. But then we're also allowed to take 10 away on the outside here. So the smallest value we could get for our function is going to be -10, which happens to be the domain that we defined for f of x. I guess I should finish this up and replace it with f inverse of x here. Okay, so we still have that domain range rule in effect here. All right, so now we're going to let q of x equal x squared plus 6, and we're going to let it be defined on the domain 0 to infinity. And we want to find q inverse of x, and we want to find its domain. Okay, so let's figure out what the range is here for q of x. All right, so we know that q of x is divided on 0 to infinity. So if we plug in 0, we will get q of x is equal to 0 plus 6, which is 6, okay? So we know that the smallest value we can get for q of x is 6. So the range will go from 6 to infinity. And we know it can go into infinity because as we make x bigger and bigger and bigger, q of x is going to get bigger and bigger. So we can pick any value we want and go as high as we want. So we know the highest value, I guess, would be infinity. We can go off forever. All right. And this is also going to be the domain of q inverse of x. All right, so let's go ahead and find q inverse of x. So step one, we're going to replace q of x with y. So we have y equals x squared plus 6. All right, then we switch x and y. So we have x equals y squared plus 6. Step 3, we solve. So we'll have y squared is equal to x minus 6. And then we can take the square root of both sides. And we'll get y is equal to the square root of x minus 6. Okay? So, step 4, we replace y with q of x, or q inverse of x. We have q inverse of x is equal to the square root of x minus 6. Okay? Which makes sense that the domain would be 6 to infinity. We can't have anything less than 6 here, because if we had maybe 5 minus 6, we'd have a negative number, and we'd leave the real numbers altogether for that. So it makes sense that the domain here is 6 to infinity. All right, so that is the basic process for how you would find an inverse function. There's a few other examples of this you might run across in your homework. So if you have any questions about those, please feel free to reach out and let me know. I'd be happy to make an extra video on that, or just answer your question individually if you want. But yeah, these really aren't too bad if you just remember these 4 basic steps.